So today we're going to take a look at some examples of working with similar triangles so that you guys can get exposure to the different problems that I'm going to ask you. Okay, so remember the goal of similar triangles is to have a little bit of information about two triangles, and then if we can say that based on that information they're similar, then we can use the little bit of information to get more information. Okay, so the idea is we can only find a little bit of information, but we can say that two triangles are similar, so then we can extrapolate that information into something we want to use. Okay, all right. So here's the first question. Write a similarity statement for the two triangles and calculate the lengths of the unknown sides. Okay, so first look at what it's asking, right? Lengths of the unknown sides. So that means we want to find y and we want to find x. Okay, so x is this side right here and y is this side right here. Okay, so first you want to figure out what's the question actually going to be asking me to do. Okay, so similarity statement, remember, has to be in the form of either two angles match, or a side angle and a side match, or all three sides match. Okay, so right now, I know this side, and I know that side. Okay, I know this side, I don't know its corresponding side, and I know this side, I don't know its corresponding side. So that means I won't be able to use sides, because I've only got one pair of sides. So angles, well, first of all, we can say that angle C is common. Okay, so that's done. Okay, then we can say angle, well, there's a parallel line here, so that means there's going to be an F pattern right there because there's two parallel lines. So that means that we can say that angle ABC is equal to angle DEC. Okay, so remember, that means we've got two angles, and that's enough. I know that this third angle is the same because of parallel lines, but I also know that two angles is enough because it's just 180 degrees inside a triangle. Okay, so as soon as I know two angles, the third one's done. Okay, so now we can make our similarity statement, right? So that means, so let's call the first one ABC just to be alphabetical. So angle ABC is equal to, and now we have to find the order of the other angle, right? Remember, that's very important. So C is common to both, so that means wherever C is in this one, C has to be in the second one. And then we said, well, ABC is the same as DEC, right? So angle B was the same as angle E, so that means wherever B is, that's where we have to have angle E. Okay, and then the leftover one, D, matches with A, and that means that D goes where A is, right? So see how all the angles, so A is corresponding to D, first. B is corresponding to E, second. C corresponds to C, third. Okay? So that's our similarity statement, and we can give a reason because it's angle, similarity. Okay? So this is our similarity statement. Two angles, the similarity statement between the actual names of the triangles, and then the statement that it's angle, similarity. Okay? All right, so that's number one, done. Okay, so let's go on, or sorry, A, done. So let's go to B. Okay, so B actually asks us to find the unknown sides. Well, remember the other thing that we said about similar triangles was that the ratios of the corresponding sides are the same. Okay, so now look here, because we wrote the similarity statement in order, we can say that AB over DE, so the ratio of AB to DE is going to be the same as the ratio of BC to EC, and that's going to be the same as the ratio of AC to DC. Right? So it took a little bit of information that we knew about the triangle, and now because they're similar, we can say another bit of information. Okay? So now, for length y, or sorry, let's do x first. So for length x, we need the relationship between AB and DE, because we know that already. Okay, so we have some known information. And also x is DC, So I want to find the ratio with DC in it. Okay, so that's the other ratio that I want to use for x. Okay, so now let's write that down. So AB over DE is 8 over 5. Okay, and AC over DC is 13 over x. Okay, so now all we have to do is solve for x. Okay, so we solve for x by cross multiplying, right? So we can multiply x to that side and multiply both sides by 5, and what we get is 8x is 5 times 13. So now we can divide both sides by 8. So we get x is 65 divided by 8, which is about 8.1. Okay, so there's our length of x. Okay, now let's do the y. Okay, so let's look at what we need for y. Well, y, again, AB and DE are given. So I want to use AB and DE. Okay, but y is BC. So I want to find the ratio with BC in it. Well, there it is. Okay, so now let's fill in the blanks with numbers. And AB over DE is 8 over 5, right? So this is finding y. So AB over DE is 8 over 5, and that's supposed to be equal to BC over EC. So BC is y over 7. Okay. So now we just want to isolate y, which means multiply both sides by 7. So 7 times 8 is 56 over 5 is y. So y ends up being 11.2. Okay, so we found y is 11.2, and we found x is 8.1. Okay, so similarity statement and the two missing lengths. Okay, so let's go to another example. Write a similarity statement for the two triangles again and determine the labeled measurements. So in this case, we don't have parallel lines. Okay, one thing you should notice that you have right away is this statement right here. Okay, so this angle is the same as this angle. Okay, so let's write that down right away so we don't forget. Okay, so angle FDE is the same as angle GIH. Okay, and that we call given. Okay, so we know one angle. Okay, we definitely don't know another angle. I know the size of that angle, but I don't know the size of that angle. Okay, but remember now what the different possibilities for similar triangles are, right? Angle is one of the possibilities. It's actually going to be the most useful of the possibilities, but there are other things that we can use. Okay, so angle is one of them. The other one was side, side, side. Well, I've only got 1, 2, this side's missing. Okay, I've got 1, 2, 3 sides here, but this side's missing, so I don't have side, side, side. But I do have side, angle, side, side, angle, side. Okay, so all we have to make sure is, do those ratios match? Okay, so now the question is DF over GI the same as, so that's a question mark, DE over IH? Right? So remember, if we have two side ratios with an angle in between them, that's okay. Okay? So DF over, so I'm going to set up a little left side, right side. All right? So left side is DF over GI, so DF over GI, 4 over 2. And so that's equal to 2. Right side is DE over HI, so that's 5 over 2.5. Well, that's equal to 2 as well, so that means yes. Okay, so this is our reasoning. 1, 2. Okay? And now we can say, well, therefore, triangle will start with D, and the corresponding one to D is I. Okay? And then the next one, if I go F, then I've gone along that 4 side, which matches the 2 side, right? That's the corresponding side. So if my next one is F here, so DF, the next one is G there, G. Okay, and then the leftover is E, and the leftover is H. Okay? And our reason that we give for that is side, angle, side, similarity. Okay? All right, so we've written similarity statement. Okay? And now we want to determine the labeled measurements. Okay, so X is the first one. That's the angle. Well, since H matches E on my list, right? H matches E, it means that those angles are actually the same. Okay, so I can say E equals H. Therefore, angle E is 43 degrees, and angle H is 43 degrees as well. Okay, so X is 43 degrees. Okay, I don't need to see all this work. You could have just written X is 43 degrees. I'm just showing the reasoning. Okay, so X is equal to 43 degrees. That's done. Now, the next question is, how do we figure out Y? Okay, so I'll do that in a different color. Okay, so how do we figure out Y? Well, we know that this side is twice as big as that. This is twice as big as that. So the scale ratio between those two triangles is 2. And we can figure that out right here. Okay? So scale ratio is 2. Okay? But also we could just set up a ratio just like we did back here, right? So just like that. So that means we can say 2 over 4, for example. So let me just get rid of this. Okay, so we can say 2 over 4, because those are matching sides, is equal to, the side that matches Y is that 2.8, right? Because FE matches GH in our list. FE matches GH, so that means that 2.8 over Y is, so if this is 2 over 4, then this is 2.8 over Y. Okay? So now I can cross multiply, and I get 2y is equal to 4 times 2.8. Okay, and then I'll divide both sides by 2, and I end up with the fact that y is equal to 5.6. Okay, so up here, the length of y is 5.6. Okay, all right. So let's look at one more quick one. So this one is actually in words. Okay, there's no diagram, but it does tell you the triangle ABC is similar to triangle XYZ. Okay, and it tells you that AB is 10 centimeters, BC is 12 centimeters, AC is 14 centimeters, and XY is 4 centimeters. And you want to figure out the length of YZ. Okay, so I'm going to help you start this one. Okay, so I know XY is 4. Right? And then the question is, what's YZ? Okay? Alright, so what we have to do is we have to find the matching ratio in the ABC triangle. So XY is the beginning, right? So XY, and then YZ is the last two. So that's AB over BC. So that means AB over BC is equal to XY over YZ. Okay? So now we'll do our cross multiplying thing, and we get 10 YZ is 12 times 4. So that tells us that YZ is 48 divided by 10, 4.8 centimeters. Okay? All right. So that's that. And make sure you rewatch the video if you need to. All right. Have a good night.